When you're trying to do something so disruptive and novel, like Jiva is doing with Soliboard, you're going to face natural pushbacks.
So we had people who were very passionate about that, seeing this potential of really attacking the substantial issue of electronic waste in our modern society.
Soliboard PCBs can actually be dissolved in water at end of life, which allows you to recover the electronic components and the precious metals.
But that's a very, very important step, that you can separate the parts, that you can separate the active components and then consider recycling and reusing them.
This is the podcast for engineers, the podcast you just have to listen to if you're interested in what's going on in the semiconductor market. Today we're talking about a really exciting topic, recyclable PCB, something that really could influence the circular economy of the electronics industry. I'm here today with two guests, Andreas Kopp, who is the head of product management for chips and discretes, as well as Jack Herring, who is the founder of Jiva Materials. Thank you both for being here.
You're welcome.
Thank you for having me.
Great. So let's paint a picture for our audiences. We have a few items sitting on our table here for those of you watching the video version of this episode. Let's talk about PCB. Why is PCB important for our industry?
A PCB, or a printed circuit board, is actually the thing which is connecting all the electronic components together in an electrical application. So it has to serve several purposes. It needs to perform electrically. It needs to perform thermally because it's the host and the cooling environment for some of the components too. It needs to be robust against everything which is facing this application in its real lifetime. So it needs to sustain all the parts together to make our electronics work.
Mm-hmm. And what are some of the drawbacks of using PCB?
So a PCB material itself, which is currently available, is mainly based out of plastics. So FR4 is the most standard used material type, which is nearly 98% of plastics only, a little bit of metal in it. So it is a compound material, which is very, very hard to recycle on its own. If you then add up several components on the overall solution, the only way to get raw materials back, if you want to recycle it, actually is to shred it. Sometimes you need to get burned, and burning plastics, you can imagine, is not a very good process to get the best out of it. So this is actually a problem which we should solve.
Okay. Are there any solutions? Maybe that leads us very nicely into our guest, Jack, who, as I mentioned, was the founder of Jiva Materials. Can you tell us, what is a Soliboard?
So Soliboard is the world's first fully recyclable and natural-based PCB laminate material. So Soliboard PCBs can actually be dissolved in water at end of life, which allows you to recover the electronic components and the precious metals in a much more environmentally friendly and efficient way than the FR4 that Andreas mentioned. So it's a very exciting development for the industry.
Okay, for our audience, if you're familiar with PCB, you know it's this typically, if you break open a computer, you see these green boards with all of the circuitry on it. A Soliboard looks a little bit different. Jack, can you tell me about what we're seeing here on a Soliboard?
Yeah, so the big factor in Soliboard is its appearance. The fact that we can see the natural fibres that we're using distinguishes it from the glass fibre and epoxy based incumbent materials in the industry. So it's been very, very exciting, and a lot of our customers, including Infineon, are very excited just by the appearance. It strikes you.
But how exactly does it work? Can you walk us through the life cycle of a Soliboard?
Sure. So at the end of life of a product, you would remove a PCB made out of Soliboard. You would then put it through our novel water-based recycling process. We suggest taking a PCB, immersing it in hot water just below boiling point for around 30 minutes, and the board will break down, the components will loosen enough for you to be able to remove them, and then the natural fibres can be composted and the electronic components can be repurposed, and that's something that we've been working on with Infineon.
Okay.
That's exactly where our interest was into, to also see how do our devices perform on one side in the first life on the SolarBoard solution, and then the second part also after being disassembled, after being recycled. Can these products sustain a second life? So to have the first thoughts of a circular economy also in mind with our power components.
Okay, I've seen this in action before. So at the end of this boiling process, you're left with something like a burlap sack, basically some organic material, and the chips practically fall off, right? So Andreas, you wanted to test if they were able to be used after this recycling process then, right?
Yes, so we have designed our products, of course, to sustain very harsh environment. And in Finland is very much well known for good quality and reliable products in the market. But what we have not designed them for is to boil them in cooking water for some time and then living it again. So we actually did not know on how our parts will perform afterwards. What we did is really testing them electrically again. Did this process actually harm them? Or do we see any deviations which we would expect based on our expertise? And actually there were none. So we had good quality on the first one. The second part would be then to go for another, simulating another life cycle to see would they sustain more than one life cycle of a final application. And so we're on a good way there.
Okay, so it sounds really interesting. Like this on paper could be a perfect solution to solving the PCB waste problem. Are there any technical limitations?
So the FR4 board, which we compared against, has been in the market since decades. So really expecting at that point that the novel solution is one-to-one replaceable is most likely a little bit over expectation setting. So, but it has plenty of opportunities where we see applications in environments where the material can be used very nicely and by far exceeding the application requirements. So challenging points, of course, are very humid environments, very hot temperatures over long times. We usually don't have that in human-friendly environments, and this is where we also set our first stage to test that out. It was a fridge board, which we use as a demo board also to showcase our customers on how our product perform in an application. So it would be used within the fridge and close to a compressor. Humidity, temperatures is something which is normally in the room, so in the living room where people live. So these environmental conditions are not really challenging it, as well as the complexity of the board with one layer. What we did at that point of time was very easy to do. What we also searched for is the stiffness of the material. So we see, especially for that application and that size, stiffness is good, material is good, electrical performance is good, temperature states is good. Can we use it for all applications now? Not yet. So there's some way to go, but Jack did some progress in between.
Yeah, tell me about it. How did you take this feedback and develop the product even further?
Yeah, I think SolarBoard has its place in the market. We're aware that it won't be a one solution fits all product. So, but if you have carbon factors, or if you're being driven by ESG targets, or you're trying to overall improve your carbon and environmental credentials, then SolarBoard is a great fit. We've actually made some really great technical improvements as well over the past 12 months. We've actually taken our single layer products and done some engineering and improvements, and we can now actually produce 2-layer boards with plated through holes, which is very exciting. We're aware of the humidity requirements and the testing that's expected within the industry, and we're actually doing our own internal testing and working with our partners to actually define the parameters that SolarBoard can survive within. So there might be some adjustments to those parameters or some compensations, perhaps maybe reducing the 85 test to maybe 85% relative humidity, 85 degrees Celsius. So, but we're improving that, and we're working on things to make sure that it can be as robust as possible.
Okay, great. So like any other technology, constantly getting better over time. But I'm sure you at Jiva have experienced a lot of pushback to the material. Can you tell me a little bit about your experience? Yeah,
as Andreas said, the FR4, which is the incumbent for rigid PCBs has been in the industry for decades. And when you're trying to do something so disruptive and novel like Jiva is doing with Soluboard, you're going to face natural pushbacks. I think that's why testing is so important for us. That's why we're doing pilots with so many partners, including Infineon. We need to actually demonstrate that our material is functional within the wide variety of applications and environments. So there has been pushback there. We're doing our best to negate that pushback and prove that we are a viable commercial solution.
Yeah, I guess you can always expect a little bit of pushback from an established industry or even within an established company like Infineon. Andreas, can you say anything about what that was like for Infineon internally?
So again, it's an echo of the same situation that Jack mentioned outside for Jiva. Same we have faced inside within Infineon. So we had people who were very passionate about that, seeing this potential of really attacking this substantial issue of electronic waste in our modern society. With this electrification and digitalization ongoing, so you will have growth topic there, and you have a potential to solve it. And seeing what it can do on the long run, as well as facing this people also who are more concerned about the practicability and the status as of today with statements which you love to hear in innovations environment, this will never work. But we take that comment because we have very good educated engineers with very focused arguments on that. We take that with us for our testing on how we do the testing, what we need to prove. So it's more a challenge what we need to go through to understand what are our building blocks we can rely on, what is the next steps we can go for, and how to get towards such a mature solution. As of now, of course, there is a long way until enabling at all a circular economy for electronic components. But that's a very, very important step to actually, without knowledge of a selected PCB, that you can separate the parts, that you can separate the active components and then consider recycling and reusing them. And this is a very interesting journey which will accompany us for the next, I would say, several years, to then consider how can we make out a market of that, how can we support with reuse of used components, how do we qualify them, how do we assure that they are having a second life afterwards without any quality issues.
Mm-hmm. So how is Infineon using Soluboard today? You mentioned already a demo board for refrigerators. What is the status quo? How are we using Soluboard? How do we plan to in the future?
So what we are striving towards is to increase our broadness on demo boards. So going for more complex applications, for more complex solutions. So the opening of the second layer is something which allows us to go broader. We also want to have larger solutions where we need to have a larger, more stiffer PCB. So if you think about a wallbox EV charger, this is also something which is exposed to environment, but can be sealed off in a casing, is a large power solution where the PCB needs to maintain a lot of stress thermally as well as electrically. And with this is our next step that we can use a demo board based on this material for this application, also assuring the combination of trends, actually, the electrification, our products performance with CoolSiC products, as well as with the PCB of Jiva to make that a more sustainable solution and showcase that to our customers. We have one benefit in doing so. So our demo boards are built for experts. So we are not obliged to go through all these certifications which we need to undergo to have an electronic component used in a private household. So this is the story our customers need to go on the long run. But we can experiment with that, we can showcase that, we can take the risk also for qualification in reliability environment, and this is what we are continuing to do for.
Okay, it's good to see so many steps forward going towards a more sustainable electronics industry. What about for Jiva? Do you have anything that you expect to develop further in the next few years?
I think the natural development technically is multi-layer boards. We're taking very small steps. We've gone from single layer to 2-layer boards with plated through holes within a couple of years. So our next target really is to produce a thin core laminate material, which will then allow us to break into the 4-layer markets. But I think, as Andreas said, there's so many options and available now that we have plated through holes just for 2-layer boards, and it's keeping us very busy.
Mm-hmm. It's good to see two companies passionate about decarbonization and sustainability come together to make something so great. Thank you both for being here.
Thank you.
Thank you for having me.
And if you're interested in learning more about Soluboard or recyclable PCB, we'll leave some links in the description notes. And please stay tuned for our part 2 of this series on recyclable PCB. Thanks.